Okay. All right, like I said, today we're getting into the geometry proofs. Ready? All right, so we're just going to start out using some definition stuff to see what you remember from basically from chapter 1. So what we're going to be doing is given a picture and knowing something, make a conclusion based on what's given to us. So make a logical conclusion and justify the reason why it's true. So let's name our angles here. Okay, what I know about this picture is that ray BC is bisecting angle ABD. Key word in here is bisect. What does it mean to bisect something? Right in the middle. So what's a conclusion you can make knowing that this is right in the middle? Avery.
Angle ABC and CBD are congruent.
Very good. He said angle ABC is congruent to angle CBD. So I could put arc marks here to show that. How did you know those were going to be congruent? What told us that? The word bisect. Its definition. So the reason, my justification, is the definition of bisect. If it bisects, it cuts right in half. Okay, next one. A, B, C, D. This time I know that D is the midpoint of segment AC. So if I know D is the midpoint of AC, what else do I know? What logically follows knowing that it's a midpoint? What's congruent, Alex? Perfect. So his conclusion is that segment AD is congruent to segment CD. What's telling us that? The definition of a midpoint. We know that the midpoint is the point right in the middle, making it two equal parts. So that's the definition of midpoint. All right. D, E, F, and G. Okay, this time I'm telling you to use the angle addition postulate to tell me something that's true in this picture. Angle addition postulate lets us do what? Add two angles together to equal a bigger angle. So Avery, what's it going to be? So the measure of angle DEG, because we add numbers together and the numbers are the measures, added to GEF, angle GEF. So take a look in the picture. He's saying take this angle, add it to this angle. What should those two measures equal? The measure of angle DEF. So you're putting the two smaller ones together to equal the big one. And our justification is, I gave it to you up here, it's the angle addition postulate. And we did one like that yesterday in the notes. All right, let me throw some points on here. A, B, and C. This time we're going to use the segment addition postulate to say something. Alex? Perfect. Notice I didn't put the segment bars above it, because when I don't put the segment bar, that means the length. So it's saying the length of segment AB added to the length of segment BC equals the length of segment AC. And again, I told you the reason it's the segment addition postulate. All right. This one I'm telling you I've got two congruent angles. If I know two angles are congruent, what else do I know about them? What's the same? Their what? Their measures are the same. Measures are numbers. Measures are not congruent. What are numbers? We don't use congruent for numbers. What do we use? Equals. So if I've got congruent angles, I know I've got equal angle measures. So my conclusion is the measure of angle ABC is equal to the measure of angle DEF. So if the angles are physically congruent, I know their measures are equal. And the reason there, what do you think the reason is? Definition of congruent. Congruent, same size, same shape. And our last one, if I've got two congruent segments, what else do I know is true about those segments? They're the same length. What says they're the same length? Put your CD down with no bar, because once I don't put the bar above there, I'm talking about the length of CD. That's a number. That's equal to the length of GH. So the physical segments are the same. I can pick them up and hold them and show you they're the same, but now their lengths are equal. And the reason? Definition of congruent again. Okay. So this is kind of a lead into the geometry proofs that we're going to do. And we're going to start the geometry proofs very simple, where they're going to give you all of the statements, and it's your goal to supply all of the reasons over here. So you need they usually have a picture. They always have a picture. So here's the picture that goes with this. A, B, C, E, F. Okay, so here's what I'm given. I'm given that B is going to be the midpoint of segment AC. That tells me something. And I know that segment AB is congruent to segment EF. So I'm starting with all of that given information. So we're going to go through a proof. Well, this is a proof all the way down to this last line. But let's start here. How do I know that B is the midpoint of segment AC? So what's my thing that says it tells me? The given information. Just like yesterday when they started out with a sentence, that was our given information. This is B is the midpoint of AC. That's in my given information. So we're going from B is the midpoint of AC to knowing that BC is congruent to AB. Let me tick mark that. What lets me put tick marks there and say those are equal? It's a midpoint, definition of midpoint. That's the logical conclusion. Knowing I have a midpoint, I can get the two congruent segments. Okay. What allows me to say that AB is congruent to EF? AB is congruent to EF. That was up in the given also. They gave me two pieces of information. So given AB is congruent to EF, that's given. Given. And then BC is congruent to EF. How can I say BC is congruent to EF? Nick?
BC and AB are congruent and AB is congruent to EF.
Yep, and there's a property that goes with that. You're right, you linked the two correct things. What's that property called? Do you remember it? It's the transitive property. Because you had AB congruent to, BC congruent to AB, and AB was congruent to EF. See how they're linked right here? So we go BC to EF. That's our transitive property when we put those two things together and make that quantum leap. Nice job, though. You picked out the right two. Transitive property. There is your first geometry proof. They're not bad, but you got to know a lot of the definitions. All right, next one. Let's try another. We're given that the measure of angle A is 60 degrees, and the measure of angle B is 2 times the measure of angle A. Okay. You see our goal at the end here is going to be able to say that A and B are supplementary. But let's start at the beginning. They're giving us all the steps. What allows me to say that the measure of A is 60 and the measure of B is 2 times the measure of A? That's the given information. That's what I'm starting with. Okay, what allows me to say that the measure of angle B is 2 times 60? Not quite. I was given that it equals 2 times A. Michelle?
The substitution part?
Right, because I know A is 60, so wherever I see an A, I'm allowed to put in a 60. So they put in a 60 here, so that's substitution. So B equals 120. That's just simple. We just actually did the 2 times 60. That's to simplify. All right. The measure of A plus the measure of B equals 60 plus the measure of B. This is the one that's hard for people to see because it's written horizontally. Anybody see it? I'm going to write over to the side here where it's coming from. You agree we had the measure of A equals 60. You agree I can add the same thing to both sides of this equation? So I can add the measure of angle B to this side and add the measure of angle B to this side? What allows me to add a number to both sides of an equation? The addition property of equality. So because it's written horizontally, it's not quite as obvious what's happening there because we always write underneath vertically and then we do the adding. They just took this sentence here and added the measure of angle B to both sides of it. So this was the addition property of equality. They added the measure of angle B to both sides of this equation. Now what changed? How'd they get from line 4 to line 5? I heard it. Substitution, because we know B is equal to 120, so in place of the B they put the 120. That's substitution. Then what happened to get to line 6? They simplified. They actually added the 60 and the 120. So my line 6 says that the measure of A plus the measure of B equals 180. You had to go give more blood today.
No, I had to get an MRI and then.
Ah, you're having some issues. All right. So what allows me to say that A and B are supplementary? They equal 180 because that's what? That's the definition of supplementary. If they add up to 180, which they do, then we can say they're supplementary by definition of supplementary angles. A little trickier, but you'll get the hang of them. The more we do them, the better you'll get at them. All right, another one. The more we do together, the better off you'll be. Given angle A and angle B are complementary. So we've got an angle A. We've got an angle B. And we've got an angle C that's congruent to A. I'll put arc marks in there because they told me it right here. A and C are congruent. Oh, Christine, you want some notes? That'd be helpful. Let's see. There you go. Okay. How do I know angle A and angle B are complementary? It's in the given. Angle A and angle B are complementary in the given. What lets me say that the measure of A plus the measure of B equals 90? The definition of complementary. Remember, complementary means they add up to 90, and that's what they wrote. A plus B equals 90. That's right from the definition of complementary. What says A is congruent to C? The given. What says the measure of A equals the measure of C? Definition of congruent. Here I said they were congruent. If they're congruent, I know their measures are equal. The measure of C plus the measure of B equals 90. Avery?
It says that A and B are complementary and A is congruent to C, so it's the same as A.
Well, I don't want to try and write all that down there. Holy cow, we'll be here all day. Alex? What, if it's, you should be able to tell me the two you're linking together if it's transitive.
It says A and B are congruent, so it'd be angles B and B are complementary. You're like switching.
You're close. Anybody else give me something easier? If I told you to put,
Substitution.
yes, with which two sentences? 2 and 4. I've got measure of A plus measure of B equals 90. And I know that A is equal to C. So wherever I have an A, I can put a C. So if I put C here, I'll have C plus B equals 90. So it's a substitution using 2 and 4. You don't have to put the 2 and 4, but if you look back, you'll know which ones we used. But this part's not necessary, the fact that we just used substitution. So we took sentence 2 and substituted in C for the A, and now we got this new sentence. So what allows me to say that angle C and angle B are complementary? Right here I said they add up to 90. What does that mean when they add up to 90? They're complementary by the definition of complementary. All right. A theorem is any statement that can be proved a two-column proof. This, what we did just now 3 times, is very, very, very similar to a two-column proof. You have statements in one column and reasons in the other column. Your reasons are your justifications. So we are going to prove a theorem. Okay, the linear pair theorem. If 2 angles form a linear pair, then the 2 angles are, what's a linear pair again? They are adjacent and They do, because you got the word line in there. They're adjacent and they add up to 180. So angle 1 and angle 2 form a linear pair. So what's my missing line here? If the two angles form a linear pair, then the two angles are supplementary. So the shortened version says, if it's a linear pair, then you have supplementary angles. All right, prove the linear pair theorem, use a two-column proof. So we are given, here's our picture. The only thing I know is that angle 1 and angle 2 form a linear pair. Of angles. We want to prove that angle 1 and angle 2 are supplementary. You're not at the point where you can just be given a blank proof and fill the whole thing in, and you don't have that on your homework at all. It's going to be more like the other side where they give you one side and you supply the other side. So don't panic on this yet, because this is not what you're expected to be able to do on your own yet. So two-column proof. Over here, we just did the two columns and I didn't label them. There was nothing up on the heading here. An actual proof labels them as statements and reasons. All right, so you always start, what do you think you start a proof with? Any guesses? Always start with your given information. If that's all the farther you can get on a quiz, well, at least you got 1 point. You always start with what's given to you. So angle 1 and angle 2 form a linear pair. The reason I can write that down? Given. Show you something real quick, so I don't want you to dig your notes out. Should have had this handy. Okay. Here's our definition of linear pair, and we had this back in chapter 1. Linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Okay? So that's the definition of a linear pair. They have to be adjacent, and the sides that they don't share are opposite rays. So, by that definition, I am allowed to say, let me throw some points on here. A, B, C. What am I allowed to say because of that definition? Where are my opposite rays in that picture? BC, ray BC, and what's the other one? Ray BA are opposite rays. And what did I just look up in order to say that? Definition of linear pair. So I've got a pair of opposite rays. The measure of angle A, B, C is equal to 180. What do you think allows me to say that? Nope. Supplementary says two angles add up to 180. Straight. What kind of angle is that? straight angle. It's a definition of a straight angle. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle A, B, C. What allows me to say that? That's the angle addition postulate. When I have two adjacent angles, I can add them together to create the bigger angle. That's the angle addition postulate. The measure of angle 1 plus the measure of angle 2 equals 180. Nope. Anybody see it? Michelle?
Substitution.
Which two lines did I use to substitute?
You substituted 180 for ABC.
Yep, because here I said ABC is equal to 180. Here I've got ABC, so I can substitute 180 in for it. So I combine 3 and 4 with substitution. If I know the measure of angle 1 plus the measure of angle 2 equals 180, I think it's okay for me to say that angle 1 and angle 2 are supplementary. Why? Because of the definition of supplementary. I met the definition here. Oh, that was your first real proof. But again, you will not be given a blank proof and asked to fill the whole thing in. All right. So the thing with proofs is I make you write everything out, and they get to be a little bit long, but I don't give you a lot of them. So what do you have today? Right here. So page. No, page 113. I'm only giving you 1, 2, 4, 6, and 7. But you do have to do a lot of copying. Every proof has to have the picture. You have to write out what's given and what you're trying to prove. And you have to write out everything in the 2 columns. So a lot of it will just be copying because they're going to give you a lot of the information. And you've got to fill in the blanks. But the 2 columns, if I don't see everything written down for every problem, it's not just fill in the ones that are missing, you're getting a 0. I'm only giving you these 5 problems. I want everything written down. Should take a front and a back, pretty much, for these 4. Look at how long that is. Okay.